Hello, my name is Adi Nugraha. I'm from Indonesia.
Hello, my name is Mardianto. I am from Toraja.
Hello, I am Muhammad Habibi Al-Bistami. I am from Blitar.
Hello, my name is Taufik Talentino and I'm from Jakarta.
In this video, we are going to tell you about thermodynamics in phase diagram. Enjoy it.
Well, this is our presentation about phase diagrams. Thermodynamics in material science is often used indirectly through the phase diagram. All about the equilibrium state of a system for a particular condition is a very useful starting point to synthesize material and determine the stability of the materials. Phase diagram is often associated with variable temperature and composition. Gibbs rule is an important guideline for the construction and understanding of the phase diagram. The main purpose of this presentation is to introduce the quantitative relationship between the phase diagram and thermodynamics.
Gibbs phase rule. Phase rule for the first time is introduced by Juilliard Gibbs in 1875, but only published 20 years later. Suppose that in a system there is a phase C and P pieces of fruit scattered component in each phase. The degree of freedom, or usually also called variance in F, degrees of freedom is the number of intensive variables that can be fairly fired without changing the number of phases present in the system, or the number of intensive variables that must be determined so that the value of all the remaining variables can be known, or the number of intensive variables that are used to characterize a system, reduced by the number of relationships or constraints that connect each phase. In other words, a system with phase and C or P pieces of fruit or components only explain the circumstance described by the balance complete when given intensive variables values as F. By definition, F equals C min P plus 2.
For systems that are in equilibrium, the chemical potential of each constituent must have same value everywhere in the system. If there is some kind of phase in the system, then the chemical potential of each compound must have the same value on each phase where the compound was. Phase stability of pure compound. Based on the third law of thermodynamics, the entropy of a compound is always positive. This fact shows that the micropole delta is always negative. So, the plot of micro versus T at constant pressure is a curve with a negative slope. At any temperature, the entropy of gas is bigger than the entropy of liquid, and the entropy of liquid is bigger than the entropy of solid. Axis temperature divided into three intervals. Below Tm of solid has the lowest chemical potential. Between Tm and Tb, liquid has the lowest potential. Above the Tb, gas has the lowest chemical potential. Phases with the lowest value of the chemical potential is a stable phase.
Substance standard reference SSR and standard element reference SER. 1. SSR. The enthalpy of all substance in the most stable form is at a pressure of 1 bar is equal to 0. By using state of the SSR, enthalpy formation of a pure compound can be obtained through SER. The enthalpy of the element in the most stable form is at a pressure of 1 bar is equal to 0. By using state of the SER, enthalpy formation of a pure compound can be obtained.